There are so many things each of us do in our daily lives. We eat, we sleep, and we go places. Some of us go by car. Some of us go by train. Some of us go by plane. Little plane. And even boats. What most of us don't realize is that we can use these daily activities to help us with our math. Take the circle made by the wake of this boat, for example. Now imagine that there are two inscribed angles inside of the circle intersecting the same arc, the blue and the green. Because we know that inscribed angles are half of their intersected arc, it is easy to prove that these two angles are congruent because they intersect the same arc. This is also true for tangent chord angles intersecting the same arc. Similarly, two inscribed angles intersecting congruent arcs are also congruent. Again, the same is true for tangent chord angles intersecting congruent arcs. Also, an inscribed angle and a tangent chord angle intersecting congruent arcs are congruent. There are circles everywhere, even on a plane. Take a look at this semicircle. A special theorem about semicircles is that any angle inscribed inside of the semicircle is a right angle. This is easily proved by looking at the bigger circle that the semicircle would have been a part of. The inscribed angle intersects the 180-degree arc. Therefore, it is 1/2 of that 90 degrees. Now take a look at this circular pond here. Imagine that there are two lines tangent from the street and an intersected arc. A special theorem about tangent-tangent angles is that the sum of the measure of the angle and the measure of the intersected minor arc is equal to 180 degrees. This is true because the measure of the tangent-tangent angle is equal to 1/2 of the major arc, therefore it must be supplementary to the minor arc. Now take a look at this parallelogram sign. If a parallelogram can be inscribed in a circle, which in this case is true, then it therefore must be a rectangle. Now let's look at this circular plate. If we were to inscribe a quadrilateral inside of this circle, its opposite angles would be supplementary. This is true because the individual angles of the quadrilateral are also inscribed angles and therefore equal 1/2 of their intersected arc. And so the opposite ones would be supplementary because it's half of the circle that they're each 1/2 of.
I still got
So the next time you're on a train, or a plane, or traveling, or just doing your daily life, look for things around you that could relate to math.